Chemistry is fluorine, uranium, and nitrogen. Now, let us have a dosage of fluorine, uranium, and nitrogen. Do you get it? If you don't get it, forget about it. We are going to begin to look at our March 2015 prediction by going through question 1. So we'll start by having fun in question 1 by looking at multiple choice questions, because this will be the first questions that you get in your March exam. As usual, when we do these questions and any other question in physical sciences, including chemistry, at the back of our minds, we apply the academic constitution that we call the I can. So this is a phrase that says we can solve any problem if we apply the I, C, A, and N rule. So this rule stands for interpretation of the problem. Then after doing the interpretation, we classify the problem. Then we answer our problem. Oftentimes, we look at our answer to see that it makes sense if we didn't do any mistakes. For multiple choice, this is not that hectic because already we have answers. We just have to choose the correct one. At least for long questions, we then have to look at our answers, spelling errors, numbers that we have calculated. If they're correct and they make sense, they align with the physical phenomena that we'll be studying in that specific question. Now, our question says to us that various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to D next to the question number 1.1 to 1.10 in the answer book. So we have an example here to say if you are doing question 1.11 and you think that the answer, the option that is correct is C, you simply just write the number 1.11 and the letter C. Do not write the statements. And it's important to follow instructions because if you don't, they will penalize you, they'll deduct marks. So do not lose marks by doing funny things, in as much as chemistry is fun. They further continue to say here that each question has only one correct answer. So very important, we only have one correct answer. Some answers may seem close to each other, but you must choose the most correct one. Let us break this down and see how to answer multiple choice in chemistry. Now, question 1.1 says to us that which one of the following statements is true about organic compounds? So to answer this question, you really have to go through the statements and evaluate them to see if they are true, because you're looking at the one that is true. Now, the first one, A, says organic compounds are derived from organisms only. Well, it is true that organic compounds come from organisms, but not organisms only. The problem here is the word only. They can also be derived from other areas. They don't only come from living organisms. So that is not correct. Unless if there is no any other correct answer, this will be the most correct one. Maybe we may take it. That's why we have to go through the other options. Now, the next one says organic compounds are long, unbranched chains of carbon molecules. Well, it is true that organic compounds, they are long, unbranched chains, but we do also have the ones that are branched as well. So, this also will put on hold. But already I can tell you that the two are conflicting. So definitely these two won't be the correct one. They should be a correct one because both of them, they have the truth in them. They have the truth in them, but they miss the other part of organic compounds. We then come and say organic molecules consist of weak bonds between the carbon and carbon-hydrogen bonds. Now, this one, even when I was reading it, from the time I saw the word weak, I wanted to stop reading this question because organic compounds do not have weak. They actually have strong bonds. They have strong bonds. So that is completely correct out of the equation now. Then we have D, where they say organic molecules consist of one or more carbon atoms connected by four covalent bonds to carbon or non-metal atoms. Now, this sounds really true because what we're saying here is that we have carbon, which we all know that it is made up of four valence electrons. That's why it makes four bonds. And what that means is that it can connect to one or more. So when they say one, it means we can connect to, more than one non-metal. Hydrogen, for example, is a non-metal. Or sometimes we can even have the halogens like your chlorine, or maybe bromine, and so on. And the other thing is that carbon can connect to carbon. Sometimes here we can even connect to carbon, which again, it will have four valence electrons. It will make four bonds, and that means it can continue connecting to other molecules like that. And you can extend. If you say carbon, you can extend. Maybe we can have a chlorine here, and you can see that we can do this going forward to have a very long chain. That's why they are long chains. Hence I said here, there's the truth in it, because they are long chain. They can be branched. This here can branch, so that this bond here, it gives me a C, and we have the hydrogen here. We have to have another fourth bond here, which maybe can be a C, and so you can see that these molecules, they can really become long and complex, can be branched, unbranched. They can be straight molecules. So my answer here would indeed be the D. So we are doing question 1 of multiple choice 1.1, and then we are saying here the answer is D. Now when we jump to 1.2, we are told that here, or we are asked actually, which one of the following represents the most unsaturated hydrocarbons? Well, perhaps before you answer this, you need to ask yourself, what is unsaturated hydrocarbons? Now, unsaturated hydrocarbons are the type of organic molecules that have the smallest number of hydrogen atoms in them. They must have the smallest number of hydrogens in them. Now, if you look at this molecular formulae, we can see that the best way to answer this question is to actually break my compounds into the alkanes, and alkynes. And we know that the one that will have the least amount of hydrogens will be the alkynes, because the more you have triple bonds, the more you take off the hydrogen atoms. We reduce the hydrogen atoms. So that means here I'm going to use the formula of the alkenes to say it is given by CnH2n minus 2. And we are saying here that if I look at my options, I'm given four carbons, So that means our N here is a 4. Our N here, because remember the N stands for the number of atoms that we're dealing with. Our N here is a 4, so I'm going to have a C4. And when I have a C4, it means here I'm going to have a 2 times a 2. No, 2 times a 4, because we're saying our N is a 4. So we're going to have a 4 minus 2. And this at the end of the day will give me a C4 H. So now here we have an 8, and when you subtract 1, we should get a 6 there. So this is going to be 6H. So that means I have to take the molecule that has C4H6, because we're saying this is the most unsaturated one on these three classes that we have there. So the 6 is A, so our answer here would be A. So 1.2, we're saying the answer is A, because the one that has a 6 is the A. And obviously, if you look at this, you can see that the hydrogen atoms are actually getting a lot here. However, when you look at the D here, you can see that we have the smallest number of hydrogens, and you could be tempted to say this is actually the unsaturated hydrocarbon. But you have to understand that this does not exist. We don't have a molecule that will have 4 carbon atoms and 4 hydrogens. It is not possible. You can't have it here. It is not possible. We know that when we actually have 4, we should have 6 hydrogen atoms. So this one here, it may look like the right answer, but it is not correct because it does not exist. It's not a possible molecule. Now I'll give it to you to try to look at this one. Use a formula for this one and use a formula for this one and see what you get. Here you should get the largest hydrogen atoms here, the second largest, and here is the least. Now we're going to move to question 1.3, which says to us that which one of the following is a functional group, NH2. This one would require you to have memorized the functional groups, because for me, when I look at this functional group, it is actually the amino functional group, and it belongs to the class, or what we call the homogeneous series amide. It belongs to the amide or amides, right? So my answer is simply that our functional group is amino. So the answer here would be the D. So we are on 1.3 and the answer is a D. Now moving along, well, obviously here I don't want to look at other options because, this is a straightforward question. If we go to 1.4, we are told here that the structural formulae of 2 organic compounds are shown below. Now, if you look at the structural formulae, we can see that we have the functional group here, and we have the carbon atoms that are single bonds, so it's an alkane. When we look at this one, we still have the same functional group here that we have on the first one. And this functional group, when you look at it, you can see that it is the it belongs to the carboxylic acid, the family of the carboxylic acid. Now, the question then further goes, all the other difference maybe that I see is that here we have a branched, a branched chain, and here this is just a straight chain or unbranched chain. Now, the question says to us that which one of the following terms is correct? Which one of the following terms is correct for the compounds above? So when I look at my options, I'm told about isomers here. So that means they give us a clue that these 2 structures are actually isomers, and we have to just identify what type of an isomer it is. Well, it is easy to do that because what we know about isomers is that they must have the same molecular formula, right, but different structures. And then we have different types of isomers that we have, chain isomers, positional isomers, and so on. So what I'm going to firstly do here is that I'm going to count my atoms so that I create the molecular formula to say I have 1, 2, 3, 4, 5, 6, 7 carbon atoms. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then I have here H4, 14 hydrogen atoms. Then I only have 2 oxygen atoms, so this will give me H2. I do the same this side, 1, 2, 3, 4, 5, 6, 7. So here it's C7. Then I do the same on the hydrogens. I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I still have 14 hydrogens here, and clearly we can see that our oxygen is only 2 of them. And we can see that these 2 molecular formulae is exactly the same, but the structures are different. But what's different here is that here is a straight chain, as I said, but this one is a branched chain. And such an isomer, we know that it's a chain isomer, right? Only the structure is different. So our answer would be a C. It's a chain isomer. 1.4 would be a C. We don't study stereoisomers in high school. Functional isomers would be the ones where they differ with the functional group. The functional group is exactly the same here. And as we said, the most accurate one is the chain isomer. Positional isomer would also be different because the position would vary now of our either the functional group or the branch chain, So we don't have that in this one. Going to question 1.5, we are told that the question says to us, which one of the following is the general formula for hydrocarbons with double bonds. Hydrocarbons that have double bonds, we all know that they are the alkenes, and their formula is given by CN2N. We know that, we should all know that. So A would be our answer. That is 1.5. If you don't know this, please go revise and make sure that you memorize that equation and you know that equation. Now we go to 1.6, where they say to us that the boiling point of heptane is 97.89 degrees Celsius, and that of heptane is 36.07 degrees Celsius. Obviously, we do expect that heptane should have a higher boiling point than actually pentane, because heptane is a large molecule. What that means is that heptane, we actually really going to have 7 carbon molecules. 1, 2, 3, 4, 5, 6, 7. And this will definitely give you a large molecule. You can see that this is a large molecule compared to pentane, which is only 5 molecules. 1, 2, 3, 4, and 5. You can see that this is a much shorter molecule compared to this one. This one is a large one, because they vary with the number of carbon atoms. And we know that when we have a large molecule like this, we have a lot of bonds. These lines that I've drawn here, they are a lot compared to here. Here we have a small amount of bonds. So this is to mean that if we were to increase the temperature of these two molecules so that they get to a boiling point, with this molecule, it will be difficult to actually increase the kinetic energy. We'll need more energy here to make this molecule to start boil, to change its phase from the liquid or the solid and go into a gas. We'll need a much more higher energy that we'll have to put here compared to here, because here we have only few bonds. At some point it will boil faster than this one, right? Because it's a large molecule into a small molecule. Now here, that is just the interpretation that you should have, or a picture that you should see in your mind. They then ask us here to say which one of the following statements is correct reason for the high boiling point of heptane compared to the lower boiling point of pentane. Already I've said the answer here. We have the largest molecule here, therefore the boiling point should be higher compared to here. Here we have the smallest number of carbon atoms or molecules and the bonds, and therefore they should have a lower boiling point. Now they say here pentane, right? Remember, let me just say this here. This is hept, this is pent. Now here they say pentane has the largest number of carbon atoms. No, it doesn't. You see here we have only 5. We have only 5 and we have 7 here. So this is not true. We can't have the largest number compared to heptane. Now they say pentane has the smallest number of carbon atoms than heptane. This is true actually. That's what we're saying all along, to say with pentane you have the smallest number, right? So this would be the correct answer. But let's check the other ones to be sure. Then they say here pentane has the same number of carbon atoms. No, they don't have the same number. They're different molecules. Pentane and heptane are members of the same homologous acid. Well, that's true, they are, but that has got to do nothing with their boiling point. Then we go to question 1.7. Now in 1.7 they say to us which one of the following is the hydrogenation reaction. Before I even look at my options here, the important thing that should come to mind, or that I should do, is actually to know what hydrogenation reaction is. And in fact, we all know or should know that the hydrogenation reaction is a reaction where we take an alkene or alkyne and we add the hydrogen atom so that it gives us an alkane. We go back to an alkane. So we're having an alkene or an alkyne, and we react it with hydrogen, and what we should get is an alkyne. Right, now this means that if I do something like this, I write the formula of the alkene. We know that is going to be CnH2n, and if we write the formula of the alkene, it's going to be CnH2n minus 2. And well, in fact, this question becomes easy to answer because from this definition, I can see that I need to have this hydrogen in my reaction. And when I look at these options here, the one with hydrogen is the first one on A, because here we have hydrochloric acid, we have water, we have oxygen, right? So these ones are not true. And in fact, some of them you can already spot them, this is a combustion reaction and so on and so forth. So these ones are already out because they do not fall under this definition. Right, so what you can do here to confirm your answer, I think at this stage you can choose A, but to confirm your answer, you can really come here and say, if I have 4 hydrogen atoms, because I can see I have 4 hydrogen atoms, it means here I'm going to have 8, because I'm going to have 2 times the 4, which is an 8, and that gives me the molecule that I started with. And now if I add this to that hydrogen, this reaction should actually, already I can see that I don't have an alkene, because if you put a 4 here, we'll have a C4, and then if you say 8 minus 2 is a 6, so this is already out. That means here I'm going to add my hydrogen and hydrogen here. I should have C4 and H10, because when you say the 2 here time plus the 8, it should give you H10, and that's our alkyne. We can see that this is an alkyne, right? Because is what we have here. This is an alkyne because if you then use the formula of alkyne, which is Cn2n plus the 2 here, and that means we're going to have C4H2 times 2 plus the 2. I keep on writing the 2, I don't know why, because here it should actually be a 4. This is not getting fun for me. So this is HC4, then 2 times 4 is an 8, plus the 2 is a 10, and we can see that even if when you use the formula, we actually get back to what direction has given us. So that gives you much more confidence to say the 1.7 answer should really be the A. And if we look at 1.8, they say to us, which one of the following is the correct IUPAC name for the compound below? Now, when we look at this compound, we can see that it is an unbranched chain molecule. It's a straight molecule because I don't see any branches here. And the other thing is that it is made up of a triple bond here, and also you have single bonds. So we know that the functional group here is an alkyne. Our functional group here is an alkyne. And so that means when we do this, we are going to start numbering or counting our carbons to say it's 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbons, and 8 we know that it should be an octane, because we said here this is an alkyne. But the other thing is that we have to then count where this triple bond is taking place, because remember, Y and E means triple bond. So to do that, we are going to start doing our counting from the side that is closest to the triple bond, because in this case we have a triple bond. So the side closest to the triple bond is this side. Is going to be 1, 2, 3, 4, and so on, 5, 6, 7, 8. Now this would mean that I'm going to write a 1 here to say my triple bond is located at position 1. Or another way of writing this, you can say it's an oct 1 YEN at the end, oct 1 ion, to say now that this is an octane. It's an octane, meaning it has 8 it's an oct. It has 8 carbon atoms, and in position 1 we have a triple bond, because it comes from the word alkyne. That's the simple naming that we have there. And then what option is that? Obviously the option would be B by the look of our options. And this question will need you to know the naming rules, because somebody will start counting from this side, and they start messing with this numbering that they've put here. And this cannot be octane because it's not a single bonded molecule. It has a triple bond in there. Now if we go to question 1.9, they say to us, which one of the following terms describes hydrocarbons with conjugated double bonds? Now, to say something is a conjugated double bond would mean that we have alternating double bonds in the molecule. So what do I mean? I mean that if you have a carbon here, it will be bonded to another carbon. And here we'll have a double bond. We have a carbon, then we have a single bond. We have a carbon, we have a double bond. We have another carbon here, we have a single bond. And this continues doing that like that. So what am I saying? I'm saying that we alternate single bonds between the double bonds. We call this conjugated double bonds, right? Now, when this happens, obviously you will still have your hydrogens attached and everything. So conjugated would mean that. Now, in our options, they then say A, saturated. Definitely, you can see that this won't be saturated, because when we do these double bonds, we actually reduce the number of hydrogens. So it cannot be saturated. They say polymerization. Well, the process of polymerization involves taking monomers and then combining them to form long chain molecules that we call polymers, right? So that has got to do nothing with what is happening here, because we're not really taking monomers here to make long chains here. Then see, they say unsaturated. Unsaturated would seem like a nice correct answer, because this here is an alkene, right? That means we already have double bonds, and an alkene, we all know that it is actually unsaturated, because you have reduced the number of hydrocarbons. If we just look at D just to compare and see if maybe it's close or it could be the best option, they say fractional distillation. This again, it's a different process that I think has got to do nothing with this question, because fractional distillation is a process, right, where we take a mixture and separate that mixture into small fractions, into smaller different mixtures. We put them into different beakers. So what I'm saying here is that if we have a mixture like this, let me draw a beaker quickly. Let's say in this beaker we have a mixture. Then we take this mixture, divide it, we put it in different. Let's say we divide it into two fractions. You see, these are fractions, meaning a small amounts that when you add together, if you add these two amounts together, they should go back and give you the amount we started with. So we're dividing this molecule into these fractions. And the idea here is that when we do that, the boiling points of these two should be similar. We divide them so that their boiling points are similar. That is what fractional distillation is. It has got to do nothing again with conjugated double bonds, right? So C would be really the perfect answer to this question. C would be the perfect answer to this question. Now, if we go to 1.10, we are told or asked that which formula shows atoms attached together within a molecule and all bond lines that connect the atoms. When I'm reading this, what comes to mind is a structural formula. That's a pure definition of what a structural formula is, and my answer here should be C, because a molecular formula doesn't show bond lines, condensed structural formula doesn't show bond lines. Ionic formula is also a different type of formula, it shows you the ions, right? So our answer here would be C, the structural formula. Stay tuned for question 2.